In a circle of radius r, the length s of an arc that subtends a central angle of theta radians is given by the formula s equals r theta. So let's use this formula to answer some questions. Find the length of an arc of a circle with radius 10 meters that subtends a central angle of 30 degrees. So let's pick out what we know. We know that the radius is 10 meters. So r equals 10. Clean that up just a little bit. And we know that the central angle of 30 degrees is theta. But you need to be very careful. It says 30 degrees here. But here it says theta is in radians. So while 30 degrees is correct, we have to convert it to radians. So to do that, we're going to take 30 and multiply it by pi over 180. And that will give us pi over 6. So theta is 30 degrees, which what we need is pi over 6. Now that we got everything we need, we can find the length of the arc, s. So s equals r theta. S equals 10 times pi over 6. And that's going to end up giving us 5 pi over 3 meters. But if you want a number that looks a little bit better than that, we can just convert it to a decimal, which is approximately to 2 decimals, 5.24 meters. So an exact answer is the 5 pi over 3 meters, but the approximate to 2 decimals is 5.24 meters. Next, a central angle theta in a circle of radius 5 meters is subtended by an arc of length 6 meters. Find the measure of theta in degrees and in radians. So let's pick out what we know. Radius is 5 meters, so r equals 5. And I see that the arc length is 6 meters. So that means s equals 6. So I need to find theta. Well, I know that s equals r theta. So I'm going to plug in what I know. So 6 equals 5 times theta. I'm going to divide the 5 over, and I'm going to get 6/5 equals theta. And since theta is already in radians, this is my radian measurement. That means I need to get my degree measurement by converting radians to degrees. And I do that by taking 6/5 and multiplying it by 180 over pi. And that's going to end up giving me, since we want it in degrees as well, let it get the approximation, that's going to give me 68.75 degrees. This is the degree measurement for this one. So there's degree and radian. Last, find the radius of the circle if an arc length of 6 meters on the circle subtends a central angle of pi over 6. So again, let's pick out what we know. Arc length of 6 meters, so that's s. S equals 6. And it subtends a central angle of pi over 6. So that's theta, and it's already in radians, so pi over 6. So now I just need to find r. So s equals r theta. 6 equals r times pi over 6. Now I'm just going to divide the pi over 6 over, so we'll flip and multiply, and that'll end up giving me 36 over pi meters for r. But again, if you want an approximate answer, something that you can actually look at and see a little bit clearer than this, even though this is the exact answer, the radius rounded to 2 decimals will give you 11.46 meters. So there's your exact and approximate distance for this one.